Hi everyone. Well, we're back. This is your Unit 4 notes for days 5 and 6 covering solving trigonometric equations. So in order to solve trig equations, we need to have a basic understanding of how we use the unit circle. So if you recall, before we would be asked to evaluate a trig function at a particular angle. And on the unit circle, the sine function is equivalent to the y-coordinate, cosine is the x, tangent is the y over the x, cosecant is the reciprocal of sine, so it's 1 over x, secant is the reciprocal of cosine, so it's, this is 1 over y, secant is the reciprocal of cosine, so it's 1 over x, and cotangent is the reciprocal of tangent, so it becomes x over y. So we would go to the angle given on the unit circle, and because it was sine, we would pull the y-coordinate from that. So therefore, sine of 225 is the same thing as negative square root of 2 over 2. I have a negative sign somewhere there. Okay. Because at 225 degrees on the unit circle, the y-coordinate is negative square root of 2 over 2. Cosine of pi over 4 is at pi over 4 in the unit circle, the x-coordinate, so that would be positive square root of 2 over 2, because that's the x-coordinate. Tangent of 300, we would go to 300 on the unit circle, and we would make a fraction of the y-coordinate over the x-coordinate. So the y-coordinate is negative square root of 3 over 2, and the x is 1 over 2, which simplifies to negative square root of 3. Cosecant of 2 pi over 3, we do the same thing. We go to 2 pi over 3 on the unit circle, and we find the y-coordinate, but we take the reciprocal of it. Or another way to think about that is to basically take the sine of it and then find the reciprocal of that, which is essentially the same thing. But anyway, at 2 pi over 3, we get the square root of 3 over 2. The reciprocal of it is 2 over the square root of 3. We're not allowed to have a radical in the denominator, so we have to rationalize it, which gives us a simplified answer of 2 square root of 3 over 3. Secant of 150, same type of thing. We find the reciprocal of the x-coordinate. The x-coordinate is negative 2 over the square root of 3 at 150 degrees. It's negative square root of 3 over 2, and the reciprocal is 2 over negative square root of 3. And again, we rationalize it. And then 7 pi over 6 on the unit circle. For cotangent, we put our x-coordinate over our y, which gives us the square root of 3 over 2 over 1/2, which again reduces to the square root of 3. Okay, so now what we need to do is kind of think about this backwards. So what if now, instead of evaluating trig functions on the unit circle, now we already know the value of the trig function, and what we need to figure out is the angle. So we kind of do the opposite. If it's sine, again, that's the y-coordinate. So what we're doing is we're looking for the angle measurement where the y-coordinate on the unit circle is negative 1/2. So if we go around our unit circle, the y-coordinate in quadrants 1 and 2 are all positive because we're above the x-axis. But if we go to quadrants 3 and 4, which are below the x-axis, we can start to see that now we have negative y-coordinates. So one of the values, or one of the angles, where the y is negative 1/2 is at 210 degrees. However, sine, or the y-coordinate, is also negative in quadrant 4, and we see negative 1/2 in the y-coordinate also at 330 degrees. So we actually have two answers here. And technically, we're going to see that we're going to have an infinite number of answers because the unit circle, of course, repeats itself as our angle goes around, as it rotates more and more around the origin. And what we just did there is we solved a very basic trig equation. So a trig equation basically has a variable for the angle measurement. We'll do the same thing for a cosine equation, except now we're looking for where this value is in the x-coordinate. So that would be at 45 degrees and at 315 degrees. So if you go to square root of 2 over 2 in the x, you can see that it's at 45 degrees and at 315 degrees on the unit circle. And these over here we'll do in radians, just so we get practice with both. Now tangent's a little bit harder because it's made up of two coordinates, the y and the x. So we need to work backwards here. We need to keep in mind that the square root of 3 is not going to be found directly as an x or a y because it's the y over the x. So if you took a look here and here, in order to simplify something to the square root of 3, we needed to have the square root of 3 over 2 on top and the 1/2 on the bottom. Because tangent is y over x, that means the y coordinate has to be the square root of 3 over 2 and the x has to be the 1/2. So that's what we're looking for now. We're looking for where is the x, positive 1/2, and where is the y, square root of 3 over 2. And that's going to be, again, in two locations, at 60 degrees and at 240 degrees, because in quadrant 3, both the x and the y are negative, which cancel out and give you a positive answer. So for these, we're always going to get at least two answers. We'll talk about that more as we go a little bit more in depth. Cosecant, same type of thing. It's the reciprocal, so we have to keep in mind that it's the same thing as if we're finding the sine of that angle at the reciprocal, or the square root of 3 over 2. So we would get pi over 3 and 2 pi over 3 because that's where the y coordinate is square root of 3 over 2. Secant, which is the reciprocal of cosine, we're looking for where the x coordinate is -1. So that's going to be at pi, just in one spot. And cotangent theta, the only way to get negative square root of 3 over 3 is if our tangent, or our reciprocal, is negative square root of 3 over 2 over 1/2, because we need to get the reciprocal, and so it kind of simplifies exactly the same way this one did. Or if you don't want to think about it in terms of reciprocals, you could think of it, I need my x to be 1/2 and my y to be the square root of 3 over 2, if you just think about cotangent directly. So again, that's going to happen in two locations, at 150 degrees and at 330 degrees. Again, in this case, we're looking for where the y is 1/2 and the x is square root of 3 over 2, and one of them is positive and one of them is negative, so that we simplify to a negative answer. Okay. So again, solving a trig equation means answering the question, at what angle measurement, either in degrees or radians, will this equation be true? So we just solved 6 basic ones. They're going to get a little bit more complicated. So here are the steps. And if you want to do this in your packet, pause the video and turn to page 22, number 2 of your packet. This is number 2 on page 22 in your packets. So this, you can see, is clearly a slightly more complex example. We have more going on. We're going to follow these basic steps. The first thing is going to be to simplify or rearrange the trig equation to isolate the trig expression, meaning to get your sine, cosine, secant, tangent, whatever it is, by itself. So right now, what's with it is this square root of 2. So I'm going to divide by that on both sides, which gives me 1 over the square root of 2. But when I rationalize that, I get the square root of 2 over 2. So that would be step 1, is always to get your trig expression by itself. Once it's by itself, then you're going to use the inverse or do exactly what we did. We're going to undo the trig expression, which means basically find the angle where this answer is your value. In this case, since it's a sine, we're looking for that in the y coordinate. Really what we're doing is we're taking the inverse of it. So we get pi over 4 and 3 pi over 4. That's where the sine is equal to square root of 2 over 2. What that did is that undid the trig expression, leaving us just with the 2x. So our last step would be to just solve for that variable if it's not already by itself. So we would divide both sides by 2, which would give us an answer of pi over 8 and 3 pi over 8. If you look at the directions, it says to solve over the interval of 0 to 2 pi. So because our two answers are going to repeat themselves over and over again, we have more possibilities. So we need to also include the next values. So this is going to repeat every period, but our period is only pi at this point because we've condensed it by half. So we're going to add pi n number of times until we hit a fraction or a radian that is bigger than 2 pi. Okay, so if we include that, and I think I just get rid of this now, we're going to get pi over 8, 3 pi over 8. Those were our two original answers, and then these are the new ones. 9 pi over 8, which is still less than 2 pi, so it's within our domain, and 11 pi over 8, again, still within our domain. And we just added pi to both of these answers. And we would just do that repeatedly until we hit the limit of our domain. Okay, so anyway, there's a lot going on. This is a very dense unit of information. Come with any questions. And I would just like to add before I end this video that the letter E is the most common letter in the English language, and it's found in approximately 11% of all the words. That might be useful next class. Okay, see you then. Thanks. Bye.